All right. A sequence is given by 2.5, 5, and 7.5. If the nth term is 25, find n. If the nth term is 25, find n. Okay. So by looking at it, we know that is an AP, right? Because it's increasing by fixed value. All right. You can see that increasing by fixed value. Each time you have to add a particular value, right? So let's try to set up all the variables involved in this particular question. So the first term A is 2.5. All right. My common difference is any term minus the term before it. Okay. So I can use T3 minus T2. I could also use T2 minus T1, right? But T3 minus T2, that's 7.5 minus 5, which gives me 2.5. Okay, so you can do the regular math for that. We don't have what n is. We have that Tn is 25. All right, so we can set up our equation that says that, I'll do that up here, okay? Tn is equal to A plus, open the brackets, n minus 1 times d. Right, so let's drop in. We have Tn is 25. We're looking for the n that the term is 25, right? So that's 25. A is 2.5 plus n minus 1 times 2.5. All right, so 25 is going to be equal to 2.5 plus, we're going to expand 2.5 into that bracket. I'll have 2.5 n minus 2.5. All right, so at this point, it's just basic math. This cancels out this because, they'll subtract themselves out, right? So we'll just be left with 25 is equal to 2.5 n, which we can divide both sides by 2.5. All right, so divide both sides by 2.5. That means n would be equal to 25 divided by 2.5, which is 25 divided by, that's 5 over 2, right? Which is 25 times 2 over 5. All right, 25 times 2 over 5. 5 here 1, 5 here 5, so 5 times 2 is 10. Right, so n is 10. N is 10, that's option B. Okay, so again, we just set up everything and logged in, then solved backwards to get the value for n. All right, question 2. Find the ninth term of the arithmetic progression. Okay, so we're looking for, it's quite simple, right? We're looking for T9. We're looking for T9. And what we have that A is 18. That's the first term is 18. My common difference D, so you can just do any term minus the term before it. So you could do 12 minus 18. You could do 6 minus 12, 0 minus 6, minus 6 minus 0. Whichever one you do, you get your D as negative 6. All right. N is 9 because we're looking for the ninth term, right? And we're looking for Tn. So let's plug into the formula. Our formula is, I'll do that here. Tn is equal to A plus n minus 1 times D. So Tn or T9, all right, would be 18 plus 9 minus 1 times minus 6. So that will be 18 plus 8 times minus 6. 8 times minus 6 is minus 48. So that gives me minus 30. All right, so the ninth term is minus 30. And if you continue the sequence, right, you will get to minus 30 by the time you have the ninth term. You get to the ninth position. All right. So that's question 2. Question 3, find the nth term UN of the AP. Okay, good. So when we have a question like this, right, they're asking you for the general term, or they're basically asking you to rewrite they're asking you to rewrite this in such a manner that the only variable left is n. All right, so you write the equation as a function of only n. So all the other variables would have numbers and you simplify and all of that. So let's see what we can do. We have A for this. This is an AP, right? Yes, we have A, and A is 11. Our value for D is -7. All right. So remember, for D, all you have to do is subtract, subtract the preceding term from a term. So one could have done 4 minus 11, right? So that's 4 minus 11 or minus 3 minus 4. Whichever way you get -7. So let's plug this in and see. So we have Tn is equal to 11 plus n minus 1 times what? -7. Remember, the only thing we're going to leave in the equation is n. So this would be 11 minus 7n plus 7. All right, so that will just be 18 minus 7n. All right, so that's the formula. 18 minus 7n, that's option D. All right, so that's question 3. Question 4. Find the fourth term of an AP. So we're asked to find T4. All right, we're asked to find T4. Whose first term is 2, A is 2, and then common difference D is 0.5. All right, so our formula is T n is equal to A plus bracket n minus 1 times D. That's the formula for an AP, any term in an AP. So this would be T4 is equal to A, 2 plus 4 minus 1, because n is 4, right? N is 4, forgot to write that, times 0.5. So this would just be 2 plus 3 times 0.5. This would be 2 plus 1.5. So the answer is 3.5. So the fourth term is 3.5. All right, question 5. The 11th term of an AP is 25. Okay, so again, we just set it out. Okay, so T11 is 25, and the first term is 3, and minus 3 rather. Find D, find the common difference. Okay, so if we're going to use the formula for T11, that means n is also 11, right? Because that's the 11th term. All right, so what we'll do is we'll write out the formula for T11, plug in everything, and then solve backwards to get the value for D. All right, so let's try that together. Tn is equal to, Tn is equal to A plus n minus 1 times D. Right, so that means that T11, which is 25, will be equal to A, which is minus 3, plus 11 minus 1 times D. So 25 is equal to minus 3 plus 10D. All right, so this will be 28 is equal to 10D. Divide both sides by 10. Right, so it became 28 because I moved minus 3 over, right? Good. So divide both sides by 10, you have D as 2 whole number 8 over 10, or 2.8, or 2 whole number, if you reduce that, just 4 over 5. Okay, so yes, B is the correct answer. All right, question 6. Question 6 says the first term of an AP is equal to twice the common difference. The first term of an AP is equal to twice the common difference. All right, so find in terms of D the fifth term of the AP. So we have to look for T5. We're looking for T5, right? And we are told that the first term is twice the common difference. So I can say A is equal to 2D. All right, and of course D is D. All right, and n is 5, so we should look for T5. So the equation is going to be, of course, we're going to use Tn is equal to A plus n minus 1 times D. All right, so that means we're going to have in place of A, we'll have 2D, right? And again, that's because I said the first time is twice the common difference. So then plus 5 minus 1 times D. So we'll have 2D plus 4D, all right, which is 6D. So the answer is 60. So T5 is 60. That's option A, right? So we just set up all the variables we needed, and then we just plug in. That's all. We just set up all the variables we needed and plug in. All right. Find the nth term of the sequence. Okay. So find the nth term of the sequence. So this is asking us to we'll plug in everything, all right, but then we'll just we'll leave out n. Because we don't know what n is, we'll just plug in everything and we'll just leave the Tn as a function of n. So n will be the only variable left. Okay, so we have 4, 10, 16. My value for A is 4. My value for D is 6. All right, and I'm looking for Tn. So my formula for Tn is Tn is equal to A plus n minus 1 times D. Right, so let's plug in. Tn is equal to 4 plus n minus 1 times 6. So this is 4 plus 6n minus 6. All right, so that will be minus 2 plus 6n. All right, minus 2 plus 6n is Tn. All right, so if I factor out 2, I would have 2 bracket minus 1 plus 3n. All right, which is same thing as this. So I expected to see this, but since it's a multiple choice, you don't have the freedom of expressing your answer the way you want. So if you're solving a problem and you've gotten to an answer but you don't find your answer, check if there might be some tweaking or simplification to do that might direct you better towards the right option. All right, that's option A. All right, so we're told that find the product xy if x, 3 over 2, 6 over 7, and y form a GP. All right, a geometric progression. Okay, so the rule for a geometric progression is that your common ratio is the same, right? So that means that you keep multiplying by the same number each time. Okay, so that means that my common ratio would be given by the formula is any maybe Tn over what? Tn minus 1. So if I divide any term by the term before it, I'll get my value for my common ratio, right? So that means that I would say 3 over 2 divided by x. All right. So and it's a fraction, but I'll sort that out shortly. Must be equal to, so this divided by this. All right. So that's T2 divided by T1 must also be equal to what? T4y divided by what? T3. So divided by 6 over 7. Right. So let me do each of them, right? So that means that 3 over 2 divided by x. On this side, that's just 3 over 2 times 1 over x, right? So that means on this side, I just have 3 over 2x. 3 over 2x is equal to, I'll do the same thing here. So this is y divided by 6 over 7. That'll be y times 7 over 6, which gives me 7y over 6. Okay, so I can rewrite this side here, 7y over 6. All right. Next, I can cross multiply. If I do that, I'll have 3 times 6 is equal to 2x times 7y. I would have 18. Sorry, let me just straighten out here. 18 is equal to 14y and 14xy. So if I divide both sides by 14, I get xy, which is what I'm looking for, right? So I can say xy is going to be equal to xy is equal to 18 over 14, sorry. Xy is equal to 18 over 14, which simplifies to, I think that's 9 over 7. All right, simplifies to 9 over 7. So the methods may vary, all right, but one thing that I think you must start out with is that your common ratios must be the same. All right, the other ways you could have solved this, you could have used the same method to first of all get the value for x, all right, and then do it again to get the value for y, and then you now do what's x times y, right? That's also fine, but I find this method easier, all right, by picking out strategic values or positions to work with, such that when you cross multiply you just get xy. All right, when you cross multiply you just get xy. All right, so that's for question 8. For question 9, we are told that the sixth term of a GP is minus 2 over 3. So right now this is a GP, all right. So the sixth term is minus 2 over 27. So that means that T6 is equal to minus 2 over 27. And we are told that A is 18. And we are asked to find R. All right, so what's our formula for a GP? That's Tn is equal to A times R raised to the power of n minus 1. All right, so Tn is equal to A times R raised to the power of n minus 1. So that means that T6 would be equal to 18 times R raised to the power of 6 minus 1, okay, because n is 6. All right, so I can substitute T6, right? I have minus 2 over 27 is equal to 18 times R raised to the power of 5. So if I divide both sides by 18, I would have R raised to the power of 5 is equal to minus 2 over 27 times what? Times 1 over 18, okay? Because I'm dividing both sides by 18, so I could as well just multiply this side by 1 over 18. All right, so 2 here 1, 2 here 9. So I'll get R to the power of 5 is equal to, that would be 1 over, that should be 1 over 243. All right, and if you take the negative 1 over 243, and you can use your calculator for this, if you take the fifth root of this, you get R as negative 1 over 3. Right, so that's the answer. R is negative 1 over 3, that's D. So again, methods could be, but it just starts with setting up everything and using the basic formula, plugging in and solving backwards. So, but for the algebra, you could very well take a different route. All right, so that's question 9. Let's take question 10. Question 10 says, if 6 over 9, x, 1, and y are in geometric progression, find the product x and y. The product of x and y. Okay, so if it's a GP, we know that the common ratio must be the same. Must be the same. Right, so that means that we can try, so basically any term divided by the term before it must be equal to another term divided by the term before it. Okay, so maybe we can solve for x first, and then maybe apply the common ratio. I'm just saying. Right, so let's do that. So let's go. So let's say 1 over x. So this by doing t3 minus t2, right? Must also equal t2 minus t1, right? Must also equal x over 16 over 9. All right. So 1 over x must equal that. So if I cross multiply, I have x squared must equal what? 16 over 9. That means that x would be the square root of that. X is 3 over 4. All right. So I can write this way. 16 over 9, 3 over 4, 1. So the next question now is what comes next, right? Okay. So since I have this, I can do the same thing to solve for y. All right, I can do the same thing now to solve for. So I can say y divided by 1, right? Because we have y here, okay? So y divided by 1 must also be equal to what? 1 divided by 3 out of 4, all right? So if I cross multiply that, I'll have 3 over 4y is equal to 1. Dividing both sides by 3 over 4 gives me y as 4 over 3. So that means that we have 16 over 9. X is now 3 over 4. Y is, then we have 1. Then we have y as what? 4 over 3. So we have the whole thing set out. So the question now is, what's the product of x and y? Okay, the product of x and y would just be 4 over 3 for y times x, which is what? 3 over 4, which gives you 1. All right. So again, there are different methods, right? Different ways you could have solved this, but you must have started with the idea that the common ratios must be the same. All right. So and that's the important property. So if you have a GP, the common ratio must be the same as you progress from one number to the next one. But if you have an AP, then the common difference must be the same as you progress from one position to the next one. All right. So that's question 10. Let's take on 11. All right. So 11 says that the nth term of a sequence is given by that. Find. Oh, we should find the equation for the nth term. Okay, that's fine. All right. So what this is asking us to do is to set up the system as a function of n, only n. So we're going to plug in all the other variables and then, we'll just see what we have left. All right. So working on this, by monitoring this, you would agree with me that this is a GP, all right, because it's increasing by multiplying by a particular number. All right. So yes, our A is -2. All right. R is also -2. All right. R is also -2. And that's because if you divide any number by the number before it, you get -2. So you can try that with all of them, right? So we're looking for Tn. Generally, Tn is given by AR raised to the power of n minus 1. So if we plug in, would have this for a GP, right? AR raised to the power of n minus 1. You have -2 times -2 raised to the power of n minus 1. All right, so this would be -2 raised to the power of 1 times -2 raised to the power of n minus 1. If you're familiar with your laws of your laws of indices, all right, you would have, it's going to be, since the base numbers are the same, right? It's just going to be -2 raised to the power, we add the powers, n minus 1 plus 1. All right. So that rule actually states that a raised to the power of x times a raised to the power of y gives you a raised to the power of x plus y. So if you're multiplying both terms, then you add their index, their powers. All right. So this will just be -2 raised to the power of n. All right. -2 or raised to the power of n. All right. So that's option A. All right. So question 12, we are asked to find the nth term of the sequence. Find the nth term of a sequence. All right, so A is 5. And this is increasing by multiplication. All right, multiplication by 2. So it is a GP, right? Our common ratio is 2. So A is 5 and R is equal to 2. Our formula is Tn is equal to AR raised to the power of n minus 1. So that means that if you plug in everything, you have Tn, the nth term, is given by 5 times 2 raised to the power of n minus 1. All right, so that'll be, well, if you write it the way they did, that's going to be 5 times 2 raised to the power of n minus 1. Okay, so that's going to be option D. That's option D. Okay, question 13 says, find the common ratio in the geometric progression. All right, so common ratio just means you take one number and divide the number behind it, right? Your common ratio is given by the formula Tn over Tn minus 1. So that could be T3 divided by T2 or T2 divided by T1. All right, but I could just go T2 divided by T1. All right, so just any time divided by the time before it. All right, so what's T2 here? That's log 9. And what's T1? Log 3. All right. So we can rewrite it in a manner that will be able to cancel out log something, right? We can rewrite both of them to the base of 3. I'm going to take all of this and continue over here. So log 9 can be written as log 3 squared over log 3, right? And then by the laws of logarithm, you can rewrite it up as 2 log 3. Right, so the exponent, well, we can just describe it like the exponent comes down to multiply the whole thing, right? Again, because log itself is an exponent. All right, so you can cancel out this and be left with just 2. All right, so the common ratio is 2. All right. All right, question 4 says the common ratio of a GP is 2. If the fifth term is greater than the first term by 45, find the fifth term. If the fifth term is greater than the first term by 45, find the fifth term. So your common ratio, R, is equal to 2. All right, and then we are told that T5 minus A is equal to T5 minus A is equal to 45. Okay. Okay, so let's see if we can set up what the fifth term would be. Now, generally, your term Tn is equal to A r raised to the power of n minus 1. So that means that T5 is going to be A r raised to the power of 5 minus 1 because n is 5. So this should just be A r raised to the power of 4. So this means that A r raised to the power of 4 minus A is equal to 45. All right, but we know that r is 2, so we can substitute r in and then solve for A, right? So this will be A times 3 raised to the power of 4 minus A is equal to 45. All right, sorry, times 2 raised to the power of 4. R is 2. So times 2 raised to the power of 4. So this would be 16A minus A is equal to 45. So 15A is equal to 45. That means that A is 3. All right, A is 3. So since we have A as 3, we can solve for T5, right? Because we're finding the fifth term. So we know that T5 is equal to A r raised to the power of n minus 1. All right, and A is 3, and then R is 2. So that means that T5 would be A 3 times 2 raised to the power of 5 minus 1. So that will be 3 times 2 raised to the power of 4. 2 raised to the power of 4 is 16 times 3, that's 48. So T5 is equal to 48. T5 is equal to 48. That's option D. All right, question 15. All right, question 15 says, state the fifth and seventh terms of the sequence. We're given the numbers -2, -3, -4.5, and so on and so forth. All right, so the first thing you need to determine is what kind of sequence is it. Is it an AP or a GP or maybe just a random progression? Yeah. So if it's an AP, we know that AP, if it's an AP would always have what we call the common difference. That will mean that the difference between the terms, successive terms, would be the same. All right, and we can test that out. So we can try to say d would be equal to t3 minus t2, and then d should also be equal to t2 minus t1. All right, so when we work on the first one, we'd have 4.5 minus 4.5 minus 3. So minus 4.5 minus 3, which will just give us minus 4.5 plus 3, which will give us minus 1.5. All right, and then for t2 minus t1, if you try that, would have minus 3 minus 2, which will just give you minus 3 plus 2, which will be minus 1. Okay, so it is not an AP. All right, it is not an AP, because if it was an AP, then the common difference would be the same. All right, but you're seeing that the difference between successive terms are not the same. So let's try out GP. All right, so GP has, I mean, if it's a GP, then we must have a common ratio. Okay, so that means that the quotient of a term and the term preceding it must be the same, right? So that means that R, which is T3 over T2, must also be the same thing as R, which is T2 over T1. All right, so if we test for T3 over T2, would have minus 5.5 divided by 3. I could do that as, that'll be minus 9 over 2 divided by 3. All right, which would be minus 9 over 2 times 1 over 3. All right, so 3 over 1. So you switch that to multiplication and then you do that. So doing this leaves me with negative 3 over 2, right? Yes, so 3 here 1, 3 here 3, so we end up with negative 3 over 2. All right, so let's try the next one. Sorry, divided by negative 3. My bad. Right, so negative 3. So that means this should just be positive 3 over 2. Thank you. Okay, so for the next one, R, that's T2 over T1. That's going to be negative 3 over negative 2, right, which just gives you 3 over 2. Okay, so it's okay to claim that this is a GP because the common ratios are the same, right? Again, all of these things I did, you don't have to do it by hand. You could just use a calculator for it. Just remember that for a common difference, T3 minus T2 must be equal to T2 minus T1, right? Same thing with T5 minus T4 or T7 minus T6, all right? And the same thing for a GP, the common ratio must be the same. That means that any term divided by the term before it, all right, must give you the same answer. So you can always test. So now we know it's a GP. We are now asked to state the 5th and the 7th terms of the sequence. Okay, so for this GP, we know that it's a GP. Let me give it a good here, right? So A is equal to minus 2, that's the first term, and R is equal to positive 3 over 2. All right, our rule for any term, the nth term of an AP is Tn is equal to A R raised to the power of n minus 1. All right, so that means that if I'm solving for T5, T5 would be A, which is minus 2, times, that will be 3 over 2 raised to the power of n minus 1. That's 5 minus 1, right? Simplify that to minus 2 times 3 over 2 raised to the power of 4, which would be minus 2 times 3 raised to the power of 4 is 81 over 2 raised to the power of 4 is 16. All right, so 2 here 1, 2 here 8, so we end up with minus 81 over 8. So minus 81 over 8. Obviously the answer is A, right? I think the answer is A, but let's just solve for T7. Right, let's solve for T7. All right, so T7 would also be equal to A R raised to the power of n minus 1. A is negative 2. R is 3 over 2. And now n is 7. All right, n is 7. So that would be T7 would be A, which is minus 2, times R, which is 3 over 2. And R would be raised to the power of 7 minus 1. That's 6, right? Sorry, 7 minus 1. Okay. So T7 would be equal to minus 2 times 3 over 2 raised to the power of 6, which is minus 2 times, so 3 raised to the power of 6 would be, that's 7 to 9. All right, then over 2 raised to the power of 6 is 64. All right, 64. So I can reduce this 2 here 1, 2 here 32. So my answer is just minus 7 to 9 over 32. All right, minus 7 to 9 over 32. So it's a good idea to try this out yourself. Just, you know, if you could not have done it by yourself before we started out the video, then you can pause now and take a moment to just recall the processes and resolve it yourself, just to ensure that you have maximum comprehension. Okay, so moving on. Question 16. All right, so question 16, let's take this out. Question 16 says that the sum of the first and second terms of an AP is 4 and the 10th term is 19. Find the sum of the 5th and the 6th terms. So the sum of the first and the second terms of an AP is 4. All right, so we know it's an AP, so we already know a few things. We know that the nth term must be equal to a plus n minus 1 times d, and we are told that for this particular AP, we are told that the first term a plus second term t2 is equal to 4. All right, so we can keep that. We'll do some work with that shortly. We are also told that t10 is equal to 19. All right, so we have these two informations here. Okay, so let's break down the first one. All right, so so I'm breaking down the first one here now. That would be a plus t2 would be a plus 2 minus 1 times d. All right, and that's because n is 2. All right, so we're just using the same system or formula, right? So that means that t2 will be a plus what? A plus 1d. All right, so I can write a plus d in place of t2. So this will be a plus d is equal to 4. Better still, I can rewrite this as 2a plus d is equal to 4. All right, and that would become equation 1. And then let's try out for t10. So t10 would be equal to a plus bracket 10 minus 1 times d. Right, that's a plus 9d, because n is 10. So if you apply it here, n is 10. So if you apply it here, you get a plus 9d. And we are told that t10 is 19. So I can say that a plus 9d is equal to 19. All right, so 2a plus d is equal to 4. And a plus 9d is equal to 19. So I mean, this has become like a simultaneous equation. All right, it's become like a simultaneous equation. Let me take out a different color. So equation 1 is 2a plus d is equal to 14, and then a plus 9d is equal to 19. So you could solve this using elimination or substitution method. I would work with elimination. So to be able to eliminate a, I'll multiply equation 2 by, all right, I'll multiply equation 2 by 2. All right, let's do that. So I'll multiply equation 2 by 2. If I do that, it would become, equation 1 would remain 2a plus d is equal to 14. 4 rather, not 14. Thank you if you spotted that. So 2a plus d is equal to 4. All right, but then when I multiply equation 2 by 2, I would have 2a plus 18d is equal to 38. All right, so I multiplied equation 2 by 2. All right, so I multiplied equation 2 by 2. All right, now I can subtract. So that a would cancel out, so I'll be left with nothing there. On this other side, when I cancel out, I'll have minus 17d, and when I subtract here, I would have 4 minus 38 would be minus 34. So I can divide both sides now by minus 17, and I'll get d as positive 2. All right, I'll get d as positive 2. All that's left to do is substitute. well, that's not all that's left to do, but I can substitute 2 for D in equation 1. Okay, let me use equation 1. That means that 2A plus D, all right, plus 2 is equal to 4. That means that 2A is equal to, if I move 2 over, that will become 2, right? Divide both sides by 2A is equal to 1. All right, so now I know that working over here, I know that D is equal to 2 and A is equal to 1. All right, so it's easy to solve for the 5th and the 6th term, right? T5 will just be what? A plus n minus 1 times D. Substituting in, that would be 1 plus 5 minus 1 times 2. That will be 1 plus 4 times 2. So that will be 9. Okay, so T5 is 9. All right, and then let's see, what's T6? T6 is okay, so A plus n minus 1 times D. So let's substitute. For T6, A is 1, n is 6, so 6 minus 1 times D is 2. That will just be 1 plus 10. All right, that's 5 times 2, so that's 11. All right, so when you add them up, T5 plus T6, T5 plus T6 would be equal to 9 plus 11, which gives you 20. Right, that gives you 20. So the correct option for this is option B. Option B, 20. All right, so that's for question that's question 16, I think. Let's take on 17. All right, 17 says in an AP, the first term is 2 and the sum of the first and sixth terms is 6.5. What is the first term? All right, so we have in an AP, so given that it's an AP, we know that Tn is equal to, let me switch the pen color, sorry. We know that Tn is equal to A plus n minus 1 times D. All right, okay, so in this AP, we know that the first term A is equal to 2, and we know that the sum of the first and the sixth term, so that means that A first term plus what? Sixth term, T6 is equal to 16.5. all right, A plus T6 is equal to 16.5. What is the fourth term? What is the fourth term? Okay, so we can use this to solve for, you know, any other variable that we need. T6 would be giving us A plus 6 minus 1 times D, right? So T6 would just be A plus 5D. All right, so I can substitute that here. I can say A plus 5D is equal to 16.5. That means that 2A plus 5D is equal to 16.5. All right, that's neat math. But we were told in the beginning that what? Look here, we're told that A is equal to 2, so I can drop that in. So I would have 2 times 2 plus 5D is equal to 16.5. That means that 5D is equal to 16.5 minus 4. So 5D would be equal to 12.5. All right, so that means to solve for D, we divide both sides by 5. D would be equal to 12.5, which is 25 over 2 divided by 5. Okay, so I've divided both sides now by 5. So that means D would be 25 over 2 times 1 over 5. All right, because 5 over 1, flip, 1 over 5. All right, so let's cancel out 5 here 1, 5 here 5. So we end up with D as 5 over 2. All right, or 2.5, 5 over 2 or 2.5. Okay, so now we have all we need. We know that A was given to us as 2, and D is given to us now. We've solved for D as 5 over 2, and we are looking for the fourth term. All right, so T4 will be equal to A plus n minus 1 times D as usual. That would be 2 plus 4 minus 1 times 5 over 2. That would be 2 plus 3 times 5 over 2. That would be 2 plus 15 over 2. All right, so that would give you Yes, 9.5. All right, 9.5, because that would be 19 over 2. All right, so you can do 2 over 1, do the entire math, and or use your calculator, or you get 9.5. All right, so the answer is A. That's for question 17. Let's take on question 18. All right. So question 18 says the nth term of a sequence is represented by 3 times. So let me write that down. The nth term of a sequence, that's Tn, is represented by 3 times 2 raised to the power of 2 minus n. All right. We're asked to write down the first 3 terms of the sequence. Write down the first 3 terms of the sequence. T1 would be equal to 3 times 2 raised to the power of 2 minus 1. All right. That would be just 3 times 2 raised to the power of 1. That's 6. All right. So the answer is C. All right. The answer is C, likely, but let's stop. All right, so that's the first term. Let's do the second term. T2 would be, because n would now be 2, right? So that would be 3 times 2 raised to the power of 2 minus 2. All right, because n is 2. So that would be 3 times 2 raised to the power of 0. So that will just be 3. All right. And then T3, now n is 3. That will be 3 times 2 raised to the power of 2 minus 3. So that will be 3 times 2 raised to the power of minus 1. That would be 3 times 1 over 2. That's just 3 over 2. All right, so the 3, it's T1 is 6. All right, T2 is 3. And C3 is 3 over 2. All right, so that's option C. All right, question 19 says, if the second and fifth terms of a GP are 6 and 8 respectively, find the sum of the first 4 terms. All right, so if the second and fifth terms of a GP are 6 and 8 respectively, so we know it is a GP. All right, and we know that Tn for a GP, Tn is equal to A r raised to the power of n minus 1. All right, so let's set up T2. All right, so T2, that's n is 2, would be A r raised to the power of 2 minus 1. So T2 is just AR. All right, that's just, what represents the second term. And then the fifth term would be AR raised to the power of 5 minus 1, because n is 5. So that would just be AR raised to the power of 4. So the first line can be written this way. AR is equal to 6. And then AR raised to the power of 4 is equal to 48. All right, so you could solve this by substituting AR in, second equation, and all of that. But I really just like to divide both equations, right? So this equation 2 and this equation 1, and I'll just divide both the left-hand side and the right-hand side of the system. Okay, so I would set up equation 2 divided by equation 1. All right, so I would have AR raised to the power of 4 is equal to 48, and I'll divide this side by AR. I'll divide this side by 6. All right, so I divided the left hand side and the right hand side respectively. So I would have r raised to the power of 3 is equal to 8. So if I take the cube root, I'll get r as 2. All right, r is 2. So going by this, I can substitute. I can substitute 2 for r in equation 1. I'll end up with a times 2 is equal to 6. So that means that a is equal to 3. All right, a is equal to 3. Now we have our a as 3 and our r as 2. All right, so we've sorted out these two guys here. Then comes the question, find the sum of the first 4 terms. All right, so there are two ways to do this. You could write out all the the terms and then just add up the first four. We could use the formula. We'll do both. All right. So if it's a GP, first term is 3, so that means start with 3. The next term would be 6. All right, because your common ratio is 2. That means you're multiplying by 2 each time. All right, multiply by 2 again, you get 12. Multiply by 2 again, you get 24. All right. So to answer the sum of the first 4 terms, I just need to add 3 plus 6, which is 9. 9 plus 12, which is 21, and then 21 plus 24, which is 45. All right, so the answer is option A. All right, so that's just by doing it intuitively, right? But we can also very well do it by using the formula. The formula for the sum of the GP is Sn is equal to A times r raised to the power of n minus 1 over r minus 1. All right, so this would be, my value for A is 3 times 2 raised to the power of 4, right? N is 4, right? Sum of the first 4 terms, 4 minus 1 over 2 minus 1. So this would just be 3 times 16 minus 1, which is just 3 times 15, which is 45. All right, so 45. Either way, you get 45. The correct option is A, 45. All right, so that's it for question 19. Let's take on question 20. 20 says, if the second and fourth terms of a GP are 8 and 32 respectively, what is the sum of the first 4 terms? All right, so we know that as long as it's a GP, your nth term is equal to AR raised to the power of n minus 1. All right, and so we are told that the second and fourth term of the GP is given to us. So okay, so let's try to get what the second term is. All right, so simplifying for t2, because n is 2, would be equal to AR raised to the power of 2 minus 1. So t2 will just be AR. All right, and then t4 would be AR raised to the power of 4 minus 1. T4 will just be AR raised to the power of 3. So the question, what is the sum of the first 4 terms? We can't answer that yet because we don't have A and R. All right, but we can set up the first line of the equation better by saying AR is equal to 8 and AR cube is equal to 32. All right, because T4 is 32 and then T2 is 8. All right, so this is equation 1 and this is equation 2, and I like to solve this by just dividing one by the other, right? So I'll just say equation 2 divided by equation 1. All right, so I'll have AR cube is equal to 32. That's my equation 2 divided by AR, right? And here divided by 8. So I'll be left with R raised to the power of 2 on this side would be equal to 4. So R is 2. R is 2. I can substitute backwards, so I can substitute 2 for R in equation 1 to solve for A, right? So I'll have A times 2 is equal to 8. So that means that A is equal to 4. All right. So yes, now I can now solve for the sum of the first 4 terms because I know R is 2 and A is 4. All right, what's my formula for sum of the first 4 terms? That is, sum of terms is Sn is equal to A bracket R raised to the power of n minus 1 over R minus 1. What's A? So A is 4. R is 2, so that will be 2 raised to the power of 4, right? Because n is 4, we're solving for the first 4 terms, so this is S4 minus 1 over 2 minus 1. So this will be 4 bracket 16 minus 1 over 1, which just gives me 4 times 15, which is 16. All right, so the correct option is option D, 16. All right, now alternatively, I mean, since it's just the sum of the first 4 terms, S4, you might not have had to use a formula, right? Because since my first term is 4 and my ratio is 2, that means I can set up the first 4 terms. So the first term is 4. The next term would be 4 times 2, because my common ratio is 2, right? Which would be 8. Then the next term is 16. And then after that, we have 32. All right, so we can just add up all of this to find the sum of the first 4 terms. All right, so 4 plus 8 is 12. 12 plus 16 is 28. And 28 plus 32 is 60. All right, so the sum of all of them, the sum is 60, just by adding them up. All right, so that's for question 20. All right, question 21 says, we have to find the sum of the first 5 terms of the GP. All right, so the GP is giving us 2, 6, 18. All right, so the first term is 2, A is 2, and the common ratio is 3. All right, because you're multiplying by 3 each time, right? So we can continue just to get the next 2 terms, so we can add them up manually. All right, so 2, 6, 18. 18 times 3 is 54. And then 54 times 3 is 162. All right, so we can just do this addition by hand. 2 plus 6 is 8. 8 plus 18 is 26. 26 plus 54. 26 plus 54 is that's 80. And 80 plus 162 is 242. That's option C. All right, so you could have done that. All right, just continue the geometric sequence and then add up all the first 5 terms. All right, but we could also use the formula. The formula says that Sn is equal to A bracket r raised to the power of n minus 1 over r minus 1. All right, so let's substitute. A is 2, then open up the bracket. That's 2 raised to the power of 5 minus 1. Oh, sorry, r is 3. My bad. Let me substitute again. So this would be 3 raised to the power of 5 minus 1 over 3 minus 1. All right, so I think I've substituted correctly. So I would have A 3 raised to the power of 5 is 243. All right, so 243 minus 1 over, that's 2. All right, over 3 minus 1, that's 2. So I can just cancel out and I'll end up with 243 minus 1, which is 242. All right, so you can do it, manually, or you can use the formula. Either one is fine. The correct option is option C. All right, that's question 21. Question 22. Find the next 3 terms of the sequence. Okay, so I mean, you might have looked at this for a while and still did not figure it out. This is actually a very special sequence called the Fibonacci sequence. Fibonacci sequence. That's Fibonacci sequence. That's F-I-B-O, then Nachi. All right. And the idea of the sequence is that you get a new term by adding the 2 terms behind. All right. So you just get a new term by adding 2 terms behind. So this is going to go like 0 plus 1. 0 plus 1 would give you this 1. 1 plus 1 would give you 2. 2 plus 1. 2 plus 1 would give you 3. 3 plus 2 would give you 5. 5 plus 3 would give you 8. So 8 plus 5 would give you 13. All right. 13 plus 8 would give you 21. Yes. and 21 plus 13 would give you 34, I believe. All right, so the answer is 13, 21, 34. All right, so you get the new term by adding the two terms behind it. All right, so that option, the correct option is option B. All right, the nth term of a sequence is given by that. So the nth term of a sequence is given by 3 times 2 raised to the power of n minus 2. That's Tn. All right, so write down the first 3 terms of the sequence. Write down the first 3 terms of the sequence. So we're going to find T1, T2, and T3. So for T1, n is 1, right? So that would just be 3 times 2 raised to the power of 1 minus 2. All right, so that would be 3 times 2 raised to the power of minus 1. That would give you 3 over 2. All right. T2 would be, n now is 2, right? So that would be 3 times 2 raised to the power of 2 minus 2. 2 minus 2 is 0. So that would be 3 times 2 raised to the power of 0, right? So that would just be 3. Because 2 raised to the power of 0 is 1. Okay, so that's 3. T3 is 3 times 2 raised to the power of 3 minus 2. That would be 3 times 2 raised to the power of 1. 2 raised to the power of 1 is 1, so times 3, that's just 6. Right, so the numbers are 3 over 2 first, 3 next, and then 6. All right, so that's option C. Option C. All right, the nth term of a sequence is that. Which term in the sequence is 2 raised to the power of 9? All right, so Tn is equal to 2 raised to the power of 2n minus 1. All right, so which term, all right, when would Tn be 2 raised to the power of 9? All right, so I can just plug in 2 raised to the power of 9 for Tn and solve for n, right? So I'll have 2 raised to the power of 9 is equal to 2 raised to the power of 2n minus 1. All right, so this type of equation is called an exponential equation. All right, and that's because you'll be solving, with values in the powers. And the idea behind it is simple, is that, let me write somewhere, let me use a different color, is that if a raised to the power of b is equal to a raised to the power of c, then by default, b must also be equal to c. All right, so basically, if the base numbers are the same, you can equate the powers. So the base numbers are the same, so I can equate the powers. I can say 9 is equal to 2n minus 1. All right, so that means that 9 plus 1 is equal to 2n. 10 is equal to 2n, so n is equal to 5. All right, so n is equal to 5. So it's the 5th term. That's option C, the 5th term of the sequence. All right, 25 says we have to find the next 2 terms of the sequence. So let's see if we can figure out what the puzzle is about. So here we added 4. Right, so here we added 4. Then next we added 9. Then next we added 16. And next we added 25. So if you look at those numbers, we added 2 squared, we added 3 squared, we added 4 squared, we added 5 squared. So the next one we should be adding is what? 36, right? That's 6 squared. And then the next one we should add is 49. That's 7 squared. All right, so when you add 36 to 55, 36 plus 55, we have 1, carry 1, that's 91. So we have 91 here. And then when you add 49 to 91, that'll be 0, carry 1, 15. So we have 14 rather, sorry, 14. So we have 114. All right, so the correct option is option B. All right, option B. So this was not an AP, it wasn't a GP, it was just one of those, sequences that you had to figure out. All right, so 26 says the nth term of a sequence is given by all of that. Find the sum of the second and the third terms. All right, so we should solve for t2 and t3. All right, so tn is given by minus 1 raised to the power of n minus 2 times 2 raised to the power of n minus 1. All right, so the first thing we'll do is we need to solve for t2. All right, and then we'll also solve for t3, and we'll come and add them up here. All right, what's t2? That's n is 2. That would be minus 1 raised to the power of 2 minus 2 times 2 raised to the power of 2 minus 1. So I just substituted 2 for n in, everywhere I had n. So I would now have minus 1 raised to the power of 0 times 2 raised to the power of 1. This will just be 1 times 2, which is 2. All right, 1 times 2, which is 2, because minus anything raised to the power of 0 is 1. And anything raised to the power of 1 is itself, right? So 2 raised to the power of 1 is itself, that's 2. All right, so let's take on t3. This would be negative 1 raised to the power of 3 minus 2 times 2 raised to the power of 3 minus 1. All right, so this will be negative 1 raised to the power of 3 minus 2 is 1 times 2 raised to the power of 2. All right, so this would be minus 1 times 4, which gives me minus 4. All right, so t3 is minus 4. Hence, the sum t2 plus t3 would simply be 2 plus minus 4, which is minus 2. All right, minus 2. That's option D. All right. Now 27 says, if 6, p, and 14 are consecutive terms in an arithmetic progression, find the value of p. All right. So if you're going to have an AP, the basic idea behind this is that your common difference must be the same. All right, so that means you need to find a number that you would add the same thing to get here, and then add the same thing to get here. All right, so by looking at it, I think that number has to be 10. All right, because it's going to be plus 4 and then plus 4, right? Good, so it has to be 10. All right, but just in case that doesn't work, you can just go with the like, just in case you did not think of that, you couldn't maybe figure out the number just by looking at it. You could also very well just go, the formula for your common difference D is Tn minus Tn minus 1. So the difference between the term and the term before it. All right, so I mean, this could be T is equal to T3 minus T2, and then D is also going to be equal to what? T2 minus T1. So if I play around with this, I would have 14 minus P, because that's T3 minus T2. And then if I play around with this, I would have P minus 6. So your common difference must be the same. That means that 14 minus P must be equal to P minus 6. All right, so if I move things around, I'll have 14 plus 6 is equal to P plus P. 2P is equal to 20. If I divide both sides by 2, I get P as 10. All right, I get 10 is equal to P. That's option C. All right, that's 27. 28 says, the fourth term of an arithmetic progression is 32, and the first term is minus 20. Find the common difference. All right, so what have we been told? We're told that is an AP. So we know that each term will be Tn is equal to A plus n minus 1 times D. And we are told that A is minus 20. All right, that's the first thing we are told. And we are told that T4 is equal to 37. All right, so let's set up an equation for T4, plug in our A and see what we have. All right, so T4 would be equal to A plus 4 minus 1 times D, right? So that means, T4 is 37, so 37 is equal to A plus 3D, all right? So now we can plug in our minus 20 for A. Would have, sorry, this is A, not 9, okay? So we'll have 37 is equal to minus 20 plus 3D. That means that 57 is equal to 3D. We can divide both sides by 3, and then D would be 19, I believe. All right, so your common difference is 19. That's option C. All right. So 29. All right. 29 says that the first term of a geometric progression, GP, okay, so we're told that the first term of a geometric progression given by A is 3, and then T5 is 48. All right, and we're asked to find R. All right, so we know that any GP is given by Tn, any term in the GP is given by Tn is equal to A R raised to the power of n minus 1. So that means that T5 will be given by A times R raised to the power of 5 minus 1. That's so I can just substitute, right? I have A and I have T5, that will be 48 is equal to A 3 times R raised to the power of 4. All right, 5 minus 1 is 4. I divide both sides by 3, I would get 16 is equal to R to the power of 4. Take the fourth root of both sides, I will have R as 2. All right, that's taking the fourth root of both sides. I would have R as 2. So the correct option is option B. All right, number 13. All right, 30 says we should find the fifth term of the sequence. All right, so we should find the fifth term of the sequence. So we have 2, then we have 5, then we have 10, then we have 17. All right, and we don't know what comes next. All right, so let's check. It's not a GP, all right, because you're not multiplying by the same thing. It's not an AP also because you're not adding the same thing. All right, so let's write out what we're adding each time and then see if we can come up with a pattern. So here you add 3, then you add 5, then you add 7. So I think we're adding consecutive odd numbers, right? So here we're going to add 9. 3, 5, 7, 9. So 17 plus 9 would be 26. So the correct answer is option C, 26. All right, so we're taking on question 31. Question 31 says, find the 17th term of the AP. All right, so we're going to find T17. All right, T17. All right, so Tn is equal to A plus n minus 1 times D, okay, because it's an AP. So Tn will be A plus n minus 1 by D. All right, so we have we are looking for T17. T17 is unknown, but we have A, which is the first term, as minus 6. We have a common difference, so we can find our common difference, right? Our common difference is what are we adding on each time? That's 5. All right, you could just do T2 minus T1 or T3 minus T2. You know, you would get your common difference. All right, so we can substitute and solve. We know that n is 17. So T17 would be equal to, let's use this formula, A minus 6 plus, open a bracket, n minus 1, 17 minus 1 times D. D is 5. So this would be minus 6 plus 16 times 5. That'll be minus 6 plus 80, which is 74 as a final answer. All right, 74 as a final answer. That's option C, 74. All right, 32 says the nth term of a sequence is Tn is equal to 5 plus n minus 1 squared. Evaluate T4 minus T6. T4 minus T6. All right, so we can solve for T4 and then solve for T6. And then we subtract. All right, so for T4, n is 4, right? So that's n is 4. So T4 would be equal to 5 plus bracket 4 minus 1 squared. So this would be 5 plus 3 squared. This would be 5 plus 9, which is 14. All right, so T4 is 14. Solving for T6. T6 is 5 plus 6 minus 1 squared. That's 5 plus 5 squared. This is 5 plus 25, which is 30. All right, so T4 minus T6 would be 14 minus 30, which is minus 16. All right, minus 16. That's option D. All right, that's for 32. All right, 33. 33 says if un is equal to, all of that, so evaluate u5. All right, so the fifth term minus the fourth term. All right, so for this question, we would solve for, so we are told that un is equal to n bracket n squared plus 1. So evaluate u5 minus u4. So let's solve for u5, then we'll solve for u4, and then we'll now, subtract. So for u5, n will be 5. So this will just be 5 bracket what? 5 squared plus 1. This will be 5 times 25 plus 1 is 26. So this is going to be 130. Right, that's u5. u4 will be 4 bracket 4 squared plus 1. So this will be 4 bracket 16 plus 1. This will be 4 times 17. This would be that would be 8 carry 2 6 8, I believe. Yes, 6 8. So u5 minus u4 would be 130 minus 68, which would be that's 62, I believe. Yes, 62. So that's 62. Correct option is option D. All right, so we just solved for u5, solved for u4, and then we subtracted. All right. Question 34 says, find the n term of the sequence, and we're giving it as 2 times 3, then 4 times 6, then 8 times 9, and then 16 times 12. All right, so for this, we know that this is T1. All right, that's n is 1. This is T2, n is 2. This is T3, n is 3, and this is T4. All right, so just by looking at it, right, it's quite easy to spot that the first factor here, all right, that goes 2, 4, 8, 16 is actually what? 2 raised to the power of n. All right, 2 raised to the power of 1 is 2, raised to the power of 2 is 4, raised to the power of 8, 3 is 8, and raised to the power of 4 is 16 times. And then for the other one, we just have 3 times n, right? So that's 3n. Because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. So the correct answer is D. The correct answer is D, 2 raised to the power of n times 3 raised to the power of, times 3n rather. All right, so I mean, more so it's a multiple choice question. So I guess one could also have easily just compared, with the options presented in the as the choices. All right. So that's 34. Let's take on 35. 35 says, find the number of terms in the arithmetic progression. All right, so we have what can we tell? We know that a is 2, and that's your first term, right? So the first term is 2, and then your common difference here is negative 11. Okay, again, because you're subtracting 11 each time, right? So or you can just use the formula that we had, that's tn minus tn minus 1. So you can just pick any term and subtract. So I can say minus 9 minus 2, that gives me minus 11, right? So again, whichever way works. All right, you could do minus 20 minus 9. All right, so that's t3 minus t2 now. So that'll be minus 20 plus 9. That's minus 11 also. All right, so d is minus 11. We are told that d is minus 11. We are told that n. Okay, good. So we're trying to find n. That's the unknown. But we know that the term itself is 141. So we can use tn is equal to a plus n minus 1 times d, right? And then just solve backwards for n. All right, so tn is, so we have negative 141 is equal to a, which is 2 plus n minus 1 times minus 11. So this is minus 141 is equal to 2 minus 11n plus 11. So minus 141 minus 2 minus 11, when I collect like terms, is equal to minus 11n. All right, so this would give me minus 154 is equal to minus 11n. And when I divide both sides by minus 11, I should get n as 14. All right, so yes, n is 14. That's option D. Okay, so 36, let's see 36. 36 is find the sixth term of the sequence. All right, and we have 2 over 3, 7 over 15, 4 over 15. All right, so the first thing we need to decide is what kind of sequence is it. All right, is it an AP or a GP, or just a random sequence, and we would have to figure it out. All right, so if it's an AP, which we'll test for first, we know that common difference would be the same, right? It's constant. That means that your common difference D is T3 minus T2 is also what? T2 minus T1. So if T3 minus T2 gives it the same thing as T2 minus T1, then you know that it's an AP, and then we can proceed. Right, so let's solve for T3 minus T2. T3 minus T2, that would be T3 is 4 over 15 rather, minus T2, that is 7 over 15. All right, so LCM is 15. We just have 4 minus 7, and we have negative 3 over 15. All right, which is just negative 1 over 5. All right, so the first attempt gave us negative 1 over 5. Now let's try again. Let's do T2 minus T1. All right, so let's try T2 minus T1 and see if it gives us the same thing. T2 minus T1 will be 7 over 15 minus 2 over 3. LCM is 15. So this would be 7 minus 15 divided by 3 is 5. 5 times 2 is 10. All right, that gives us minus 3 over 15, which is also minus 1 over 5. Okay, so we have yes, it is an AP. All right, so we've confirmed that, and we even have our common difference as negative 1 over 5. So we have A as 2 over 3. That's the first term, check. And we have our common difference as negative 1 over 5. All right, so T6 will be given by, the formula A plus n minus 1 times D. All right, what's A? A is 2 over 3 plus 6 minus 1 times negative 1 over 5. So this would be 2/3 plus 5 times -1/5. All right. If I reduce this 5 here 1, 5 here 1, so it's just going to be 2/3 minus 1. All right. That's 1/1. LCM is 3. This would be 2 minus 3. So the answer is -1/3. All right. The answer is -1/3. That's option C. That's option C. All right. Now 37. 37 says find the 8th term of the AP. Find the 8th term of the AP. So we know it's an AP. All right. What is A? A is -3. Common difference D. D is +2. All right, because it's increasing by 2 each time, right? And then N is 8. So we have to find the 8th term rather. All right. So this is going to be C8. Well, A plus N minus 1 times D. So let's substitute. So T8 would be -3 plus 8 minus 1 times 2. So that will be -3 plus 7 times 2. That will be -3 plus 14. That would be -3 plus 14. That's 11. All right, that's 11. That's option B. Option B, 11. All right, and number 38. All right, number 38 says find the 7th term of the sequence. Find the 7th term of the sequence. So let's list out the sequence. We have 2, 5, 10, 17, 28. All right, so we need to figure out what kind of sequence is it. It is is it an AP? So let's check. No, it's not an AP, right? Because we are not adding the same value each time. It's also not a GP because we are not multiplying. Sorry, this 26. We are not multiplying by the same value each time. Okay, so your common ratio is not constant. Your common difference is not constant. So the next thing to do is let's try out what the additions are, what the differences are, and see if the differences have a definite pattern. Okay. So the difference here, this is +3, then this is +5, then this is +7, and then this is +9. All right. So the next numbers would be, it has to be, I mean, you can see that the difference is increasing by 2, right? Is consecutive odd numbers. So that means that the next thing we'll add here would have to be +11, then would have +13. All right, so that will be 1, 2, 3, 4, 5. So that should get us to the 7th term. All right, so this would be 37. All right, and then 37 plus 13 is 50. All right, so T7 is 50. All right, so that's option B. Okay, great. So we've come to the end of the questions, the multiple choice questions on sequences and series. So good luck on your exam prep.